All right, here we go. I'm a scared, ha ha ha, is, let's see, there's her mass, is traveling with a speed of 13 meters per second, that's her V, at the top of a 19.5 meter high loop. Okay, what is her speed at the bottom of the loop? What keeps happening there? Okay, assume no energy is dissipated by friction. Okay, so let's go ahead and we'll fill that in as a 0, and at the initial, it's always a 0. Okay, all right, so let's look at a little picture here. So she's at the top of a loop. So she's up here, right? So that means that she's going to have EG because she's above the ground and EK. All right, so I'm going to have both of these. No springs or anything, so that's going to be a 0. And then I want to know her speed at the bottom of the loop. Okay, well, that's going to be an EK, right? And there's going to be no EG there because it's going to be at the bottom. Okay? All right. You can also get a clue to what you need to calculate by what they give you, right? So if you're given velocities, there's going to be a kinetic, and if you're given height, there's going to be an EG. Okay? All right. So let's just make these calculations. So EG equals mgh. Okay, the mass is 56 kilograms times the G times the H, 19.5. Okay, all right, and then let's see, so 56 times 10 times 19.5, it's going to be 10,920 joules, all right? But she also has kinetic energy, 1/2 mv squared. So her mass is 56 and her V is 13. Okay, so if I calculate that, 5.5 times 56 times 13 times 13, 4732 joules. Okay, all right, let me just make sure that's right. 56 times, yeah, okay. All right, so now, right, her total energy is going to be both of those together. So 10,920 plus 4732. Her total energy is going to be 15,652 joules. All right, and this is at the top of loop. Okay, all right, so let's think about a graph here a little bit. This is going to be a touch difficult, so I think I'm just going to go like this. 15,652 at the top, okay? And then 10,000 of that is EG, so that's probably to like around there. And then 4,000, so maybe half-ish of that is going to be kinetic, like that. Okay, that's good enough, right? Because this is just, these numbers would be a touch difficult. So 10,920, and then this one was 4732. Just as long as they're roughly equivalently sized, I'm good with that. Okay, all right. Okay, so now position B is at the bottom of the loop. So that's technically like on the ground, okay? So I know that my total energy is going to be the same as it was before, because that can't change. All right, I don't have any EG anymore because she's on the ground. Okay, I do want to know how fast she's moving, and there's still no springs or anything, so none of this. Okay, so if my total is this, right, I can see, based on what I have here, that's going to be the whole thing now. My EK is going to be the total amount because there's nowhere else for it to go, okay? So if I do 1/2 mv squared, okay, and then I'm going to solve for V. Okay, and again, you can practice doing that more if you need more help with it, all right? 15,652 joules, okay, divided by the mass, which is 56 kilograms. Okay, so times 2 divided by 56, it's 559, and I'm going to take the square root of that, and it will be 23.6 meters per second. I'm going to go ahead and write the answer up here for ease of use. Okay? All right, that wasn't so bad.